That'll have to work.
Okay. So here are your reminders. A kids, you take multiple choice tests tomorrow at home, while B kids are at school taking free response questions in class. Thursday, you take free response questions in class, while B kids are taking multiple choice at home. And Thursday at 3:15, all of your Unit 2 homework is due. The multiple choice is 24 questions, and you'll have 40 minutes tomorrow. And then the free response questions, there are 3 of them, and you'll have the whole class period on Thursday. Today we're going over free response questions that have to do with this unit, but I just want you to know that free response questions on any test at any time can be cumulative. So on this test, you could see questions that pertain to last unit, and it will just build all year. We'll see little bits and pieces from old units on new tests. It won't happen in the multiple choice, but it will happen on free response questions. Okay, so these free response questions are meant to be a review of the material from this unit, and they're also meant to help you practice answering free response questions. All right, the first one below is a representation of a portion of a crystal of lithium chloride. Identify the ions in the representation by writing the appropriate formula: lithium Li+, or chloride Cl-. I gave you the PDF of the notes, and there's a lot of information on there about ionic compounds and ionic crystal structures. You need to read that. The big thing about this is size. So which one is lithium, dark or light? Light, why?
It's like the more positive compound.
It's more positive, but what else? What's the difference between lithium and chloride? Just the size in general. Lithium is really small. It's number 3. It only has 2 energy levels, and it's just a small atom, small ion. Chloride is bigger. It has 3 energy levels, and it's a bigger ion. So lithium is the small one, and chloride is the big one.
We actually have to write.
Nope, you don't have to write anything on this. This is just to go over. Okay, so make sure that you're looking over ionic crystal structures. There's a lot of stuff on there, and metallic bonding as well, stuff about metals. All right, the next one is about hydrogen carbonate. The HCO3 ion has 3 carbon to oxygen bonds. 2 of the carbon to oxygen bonds have the same length, and then the third one is longer. The hydrogen atom is bonded to one of the oxygen atoms. In the box below, draw a Lewis electron dot diagram or diagrams if there's resonance for the hydrogen carbonate ion, and that is consistent. So, HCO3 minus, we have 1 from hydrogen, 4 from carbon, 3 oxygens that are 6 each, and an extra for the negative charge. Gives us 18, 19, 24 to work with. And they told us that there are 3 carbon to oxygen bonds, and then the hydrogen is bonded to an oxygen. You could write this many different ways, but it has to be kind of in this order. The oxygen's bonded to the carbon, and then a hydrogen on one of the oxygens. We have 24, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. But carbon does not have a full octet, so we need to double bond. Where we choose to double bond is given to us in the problem. It tells us that 2 of these bonds are shorter, and bond length is directly related to bond order. First order bonds, single bonds, are the longest. Second order bonds, or double bonds, are shorter. And triple bonds, or third order bonds, are the shortest. But then we talked about yesterday that anytime there's resonance, that's like a 1.5 bond. If it's a double bond that could be in 2 different places. Or a 1 1/3 bond if it's a double bond that could be in 3 places. So here, by saying that 2 of them are going to be shorter, that means that 2 of them have resonance. And it has to be these 2 that have resonance because they're the same. This is in a whole different location, right? Like that wouldn't make sense. So we make it a double bond there. Don't forget your brackets and your minus charge. It's a polyatomic ion. And then we have to show resonance. On the AP scoring guide, drawing one of them correctly was worth 1 point. Drawing both of them with the arrow was worth 2 points.
Is that really just like flipping
It's flipping it, but it's saying that sometimes this one is a double bond and sometimes this one is a double bond. It's going back and forth so fast that it's almost as if it's in two places at the same time. Okay, and then it says, oh, we can erase. The next one, the Lewis electron dot diagram for C2H4 is shown in the box on the left. In the box on the right, complete the Lewis electron dot diagram for C2H5OH by drawing in all of the electron pairs. So 2 carbons gives us 8, plus 5 from hydrogen, plus 6 from oxygen, plus 1 more. 7, 12, 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There are no double bonds, so there's no resonance here. That's the only structure that works. That would be your answer. And then it says, what is the approximate value of the COH bond angle in the ethanol molecule? So we're looking here. My central atom is oxygen. It has 2 bonds and 2 lone pairs. So what shape is that? Bent. And what's the bond angle for bent? 109.5 or 107.5, depending on what's attached to it. They would accept here anything from 100 to 115. Anything in that range would have gotten a point.
You have to memorize all the shape names and for electron groups and atoms.
Just the atom shape,
Just that.
not the electron group.
Like this, even square pyramidal and stuff
Yeah.
like that. Okay.
Complete the Lewis electron dot diagram for HNO2 in the box below, including any lone pairs of electrons. So we have H gives us 1 plus 5 from nitrogen, 2 oxygens, 12, 17, 18, 2, 4, 6, 8, 10, 12, 14, 16, 18. That doesn't work. Nitrogen does not have an octet, so I'm going to have to double bond. And I have 2 options, right? I can double bond here, or I can double bond here. But by only giving you one skeleton structure, they're telling me that this does not have resonance, that one of them is better than the other. How do I decide what's better than the other? What did we learn about yesterday? Formal charge. I have to assign formal charges. So I'm going to assign formal charges as if the double bond was here. Hydrogen, 1 valence electron minus 1 bond minus 0 lone pairs gives me a formal charge of 0. Oxygen, 6 valence electrons minus 3 bonds minus 2 dots is a positive 1. Nitrogen, 5 minus 3 bonds minus 2 dots is 0. And oxygen, 6 minus 1 bond minus 6 dots is negative 1. Those are my formal charges if I put the double bond here. The formal charges, if I put the double bond here, hydrogen's still 0. Oxygen would be 6 minus 2 bonds minus 4 dots, 0. Nitrogen, 5 minus 3 bonds minus 2 dots is 0. And oxygen, 6 minus 2 bonds minus 4 dots is 0. So what's better, purple or red? Purple, because I want to minimize formal charge. So the only structure they would accept here is the one that was purple with the double bond there. And lots of kids that year drew the other one. Thought they had it right because they filled all the octets and didn't get the point, because you have to pay attention to formal charge. Okay, and then based on your completed diagram above, identify the hybridization of the nitrogen atom in the HNO2 molecule. Nitrogen is making 3 bonds and 1 lone pair. So what's that? sp3. Questions? All right.